Example 3, here we go. A 216 meter square rectangular pea patch is enclosed by a fence and divided into 2 equal parts by a fence parallel to one of the sides. Okay, so rectangular, so what you want to do is draw that out. And it's telling us that this whole thing has an area of 216 meters square. Now, in addition, it said it's divided into 2 equal parts by a fence parallel to one of the sides. So students, you can divide it like this, or you can divide it horizontally like this. It doesn't matter how you divide this. You can just divide it however you want. All right, I'm just gonna divide this vertically up and down. So I am going to divide just like that. We know that the area is 216 meters square. Okay, what dimensions for the outer rectangle will be required smallest total length of fence? How much fence will be needed? So I'm looking for the smallest fence here. So fence meaning I'm gonna have a perimeter, so I would need to go in and label some things, right? I'm gonna call the base B. I'm gonna call the height or base and length and width. However, let's do width. Okay. So area, students, is gonna be base times width. Okay. Perimeter, I'm gonna have 2 widths plus 2 base, okay? But because of this extra fence here right in the middle, that's an additional width. So really, that's 3 widths. So now perimeter is 3 widths plus 2 base. All right, guys? Now, just like all other previous questions, you guys have to rewrite your equation with respect to one variable. Let's do W. So 3W plus 2, and we need to find this base. Well, we have this area formula over here. I'm looking for base, so I'm going to divide both sides by W. Base is 216 divided by W. We are going to substitute this in, 216 divided by W. So P of W equals 3W plus 216 times 2, 432 over W. Okay. I'm going to do the first derivative. I'm going to use the power rule. So P prime of W equals 3 plus, this is the same as 432W to the negative 1. So minus 1 W minus, 1 times 432 W to the negative 2. And from there, we are going to set it equal to 0 to see if we can solve for our critical point. Okay, I'm going to make it into a common denominator of W squared. So 0 equals 3W squared minus 432 all over W squared. Well, W represents your width. So the first, number one, you can't have a 0 width. If you have a 0 width, you won't be able to find, you won't be able to make a rectangle. So right now, your domain, students, must be bigger than 0, okay? But this right here can't be 0. But anyway, it doesn't matter for us anyway, because we are not going to use that in this particular application. But we can use the top and solve for 0. Okay, move 432 over to the left. Divide both sides by 3. And so we are going to get 144 equals W squared. Square root both sides. Normally I'm going to say, don't forget to write plus or minus, but we can't have a negative based on our width restriction. So right now, our width is 12 units. What was the unit? Meters. We are going to plug it in to get our base. So base is 216 divided by 12. 216 divided by 12. 18 meters, okay? We are looking for the smallest length, the smallest total length of the fence. So we are going to add them up together. So take this formula and plug in all of your bases and your width. So P equals, we have 3W, so 3 times 12, and then we got 2 bases. Each base was 18, so 18 times 2 plus 3 times 12, that's going to give us 72 meters. So let's write a complete sentence with all of these parts. You guys ready? The smallest total length to be used is 72 meters with dimensions. Let's see, it's looking for dimension 2 as well. Yep, what dimensions? With outer dimensions of 12 meters by 18 meters. Box that up. All right, guys, here we go. A farmer with 2,000 meters of fencing wants to enclose a rectangular plot that borders on a straight highway. If the farmer does not fence the side along the highway, what dimensions will be enclosed? What dimension will enclose the largest area? What is the largest area that can be enclosed? So you guys can see that all of these questions, they have a common theme, right? We're looking for the optimal amount. We have 2,000 meters. So I'm going to label my rectangle here. Base and width. If it's 2,000 meters, that is going to represent your fencing, and that is going to represent your perimeter. Excuse me. So 2,000 equals 2W plus 2 bases, all right? Now it says, oh, you know what? Don't do that, because it says here, I have a highway that I am not enclosing. Whoa. So students, I only have 1 base, all right? So 2W plus 1 base. The farmer does not fence a site along the highway. What dimension will enclose the largest area? So we are going to do area equals base times width. We are going to write it with respect to, I'm going to write it with respect to W. So I'm going to replace my base and keep my W. So over here, I'm going to solve for base by moving 2W over. So 2,000 minus 2W equals a base. Put it over here. So 2,000 minus 2W. I am going to take the derivative to find the critical points, but for me this time it's easier to distribute and use the power rule. Okay, so here we go. A prime with respect to W is just 2,000 minus 4W. Solve for it, so move 4W, set it equal to 0, sorry. Move the 4W over here. Okay, so divide both sides by 4. I'm gonna have, ooh, W, oh, come on, it's frozen, sorry. W equals 500, excuse me. All right, guys, W equals 500. I'm gonna go 2,000 minus 2 times 500. That should give me my base. So 2,000 minus 1,000. So my base comes out to be 1,000 meters, okay? This is all meters. And it's looking for the largest area. So we have the base, we have the width. Area equals 500 times 1,000. So area equals 1, 2, 3, 4, 5. 5 zeros. 1, 2, 3, 4, 5. So 500,000 meters square. So let's write that out, guys. The largest area is 500,000 meters square with dimensions of 500 meters by 1,000 meters. Box that up.